Hi everyone, welcome back to chemistry. In this video, we're going to continue talking about electrons, and we're going to learn how to draw something called an orbital diagram and something called an electron configuration for elements. So electron configurations follow the order of occupied sublevels on the periodic table. So what the heck does that mean? So electron configurations, let's actually jump down here just a little bit, just for a second. So chemists use a notation called electron configuration to indicate the placement of electrons in an atom, to show how electrons fill energy levels and sublevels in order of increasing energy, right? They fill the lowest bookshelf first. And then to write an abbreviated form and represent all of the electrons preceding a noble gas. We'll talk about what that means. So just back up here. When you're looking at the periodic table, what's also cool about it, in addition to all the other things I talked about last week, is that it actually has these blocks where you can see here we've got our S block. Over here, we've got our D block, we've got our P block, and we've got our F block. And these blocks show us the orbitals that electrons for an element can reside in. So, for instance, over here, the first two groups, that's called our S block. So, the period number also shows what energy level you're in. So let's write period number, energy level. Remember that n equals 1, n equals 2, and so on. So if your energy level is 1, n equals 1, then you are in the first row or period. If your energy level is 2, you're in the second row or second period, okay? So there's also, we have our P block as well. And remember, generally speaking, and there are exceptions, your S is lower in energy than your P, which is lower than energy than your D, which is lower than in energy than your F, okay? We'll talk about what the exceptions are, because sometimes once you get to this period here, period 4, the filling is a little bit different, okay? All right, so we also have a D block, right? So, and that's showing our D orbitals, okay? And then our F block, which is our F orbitals. We're never really going to use the F block in this class. You will in future chemistry classes if you go on to take, higher level chemistry. But we're typically going to stay in periods 3 and above, okay? All right, so let's scoot over here for just a second because I want to show you another way, another view of this on the periodic table with our actual elements. So, and I have my link there. This is I got from Chem Libre texts. It's actually a really good study website if you need more information on chemistry. So check it out if you need more study materials. So looking here, you can see we've got our energy levels, right? 1, you see that 1 here, 2, 3, 4, that's our energy level, right? And then our S is the sub-level that we're in, right? Our sub-level is S. And remember, anything on these two first columns is your S block, okay? Oh, sorry. I also meant to tell you that helium is included. See how it's blue over there? Even though we leave it over here with the noble gases, it is part of the S block. Okay, so if you're helium, you live right here as far as the S block is concerned, okay? Or electron configuration. And then the second period, we've got our 2S sublevel. And then we've got our 2 P's, because remember, once we get down to the second energy, or up to the second energy level, we have P orbitals now. Okay, the first energy level only has those S orbitals, But the second energy level, we have s orbitals and p orbitals available to us, okay? And then we've also got, you know, some d orbitals and f orbitals. So I just wanted to show you this other periodic table, and we'll come back to it in a little bit. So orbital diagrams, remember, orbital diagrams use boxes to show electrons. So I talked about how each of these boxes are orbitals in the previous video, and that was to get you set up for these orbital diagrams. So within each of those boxes is an orbital, and within those boxes are your electrons. So orbital diagrams use boxes to show how electrons are arranged in the orbitals of an atom, how electrons fill the orbitals and energy levels from lowest to highest energy level, and how electrons fill orbitals within the same sublevel one at a time before pairing electrons. So a good example of this is carbon. And that's the orbital this is the orbital diagram for carbon here. So carbon has how many protons? 6. Yeah, because its atomic number is 6. So we know it has 6 protons. If it's neutral, how many electrons does it have? 6 electrons, right? Because if we have 6 positive charges, we need 6 negative charges to counteract that. So we know carbon has 6 electrons. And remember, these orbital diagrams are depicting those electrons. That's what those arrows are. So we want to show what electrons look like in these orbitals. Where are they? Because remember, we think about bonding. And bonding is electrons are the backbone for bonding. Okay, so, sorry, I got a little distracted there. It's so hard to work from home sometimes. So, back to chemistry. So if I have 6 electrons, I want to populate them in my orbital diagram. And remember, we're going to fill the lowest energy levels first. Lowest to highest, lowest to highest. So we're going to fill the 1s energy, or the 1s orbital first. Then we're going to go on to our 2s and then to our 2p. Okay, why don't I have p's in the 1 energy level? Yeah, we don't get our p orbitals until the energy level 2 or higher, okay? That's just not what we see in nature. So at our lowest energy level 1s, we're going to fill with 2 electrons. We're going to fill the lowest first, so we fill 2 electrons here. And then the second energy level 2s, we're going to fill with 2 more electrons. Now we have a total of 4 electrons, so we have 2 more that we need to fill. Okay, so those are going to go in our 2p's because that's the next energy level, the higher energy level. Now, when these electrons pair, or when they fill these orbitals, you'll notice that they're filling each orbital separately first. And the reason for this is that they don't want to pair up with other electrons unless they absolutely have to. Remember, electrons don't want to be near each other. So they don't want to pair up unless they really have to. So if they can just fill in 1 orbital each, they will. Okay? But if you have full orbitals, then they're gonna go like this. They'll populate here, and then here, and then here. And then they'll go spin down here, pair up, spin down here. Okay, and remember, each orbital can hold 2 electrons. So you got 2 there, 2 there, and 2 there, and that's a full, your full p orbital, or p sublevel. Sorry. But since we're carbon, we only have 6 electrons to use. So this is what your orbital diagram looks like. Okay, we only fill those 2 first orbitals. You could think of that as kind of like when you go onto the bus and it's like a mostly empty bus, but there are like a couple people on it. There's like one person on the side and another person on the other side. And imagine you just came on the bus and sat right next to one of those people who's a stranger, not a friend. Like, that'd be kind of weird, right? Normally, you're going to go pick a different spot because you don't have to sit next to the stranger. It's kind of just a faux pas or something. If the bus was full, then fine, you'll pair up, you know what I mean? But it's not full, so you're not going to do that. That's how electrons feel too. They're like people looking for a seat on the bus. Okay, so that's kind of the picture version of how electrons fill orbitals, right? You can draw out like a picture, like this. But you can also write it shorthand. So, and that's when the electron configuration notation comes in. So this shows the same thing as your orbital diagram. It just kind of writes it in a different way. So the way that we say this is we read this is our electron configuration, and we read it as 1s2, 2s2, 2p2. Okay, so 1s2, 2s2, 2p2, kind of just listing them as you go. The 1s here, let me go yellow. The 1s, 2s, 2p, what are those? Yeah, those are your orbitals. Yeah, those are your types of orbitals, just like they were up here, right? Your 1s, your 2s, and your 2p's. Remember, you have 3 of those 2p orbitals. Okay, so I actually kind of want to write this out like this. Okay, so those are your orbitals, and then the number above is the number of electrons in that orbital. So just like, again, this is carbon, so just like the one above, carbon has 6 electrons to use, and this is how they're going to fill those orbitals. So you could write this in the same way, or I mean, you could write the same information in a different way. You could say, okay, I have 6 electrons total, and they're going to fill in 1s first, and then 2s, and then 2p. Okay? I know this is kind of weird. It'll make more sense in a little bit. Okay, oh, sorry, I should color code that. We'll get rid of that. Okay, so let's take a look at the periodic table. Well, let's go through this first, and then I'll show you on the periodic table. So here, we're just looking at period 1. So in period 1, what is period 1? That's the first row, right? That's the first row of the periodic table, and it contains hydrogen and helium. And I urge you to have a periodic table right next to you as we do this. Okay, it's going to make your life a lot easier. Okay, so looking at hydrogen, hydrogen is in the 1s block. Both hydrogen and helium are. Remember, we looked at this this up here, and we said, okay, helium's normally over here, but we have it over here right now to show that it's in the 1s block, okay? Or in the s block, sorry, not the 1s block. It is in the first energy level, so it does fill the 1s orbital. But that whole side is the s block. Okay, so hydrogen is in the in period 1, so the first row, and it's in our s block. Okay, so it has 1 proton, right? Its atomic number is 1. This shows the number of protons, p plus. And so how many electrons does it have? Yeah, it's got to have the same number. Because it's a neutral atom, I haven't been told it's not. So this is what its orbital diagram would be. It fills the 1s orbital with only 1 electron. Why does it only fill with 1 electron? Yeah, it only has 1 to give, right? It only has 1 electron. So it doesn't get to be like helium. It doesn't get to fill that other electron, okay? It actually only has 1. So we can write that electron configuration as 1s. What goes there? 1. Because we don't have 2 electrons there. It's not a full orbital. We only have 1 electron. So just like up here, see how carbon in the 2p level, it only gets to 2p2. How many total electrons can the p sublevel hold? 6, right? Because each orbital in the p sublevel, and there are 3, can hold 2 electrons for a total of 6. So carbon doesn't quite get to 6. And that's actually how we know we have carbon, okay? Because carbon only has 6 electrons. It's a neutral atom. If carbon's number 6, atomic number 6 on the periodic table, it's the only one that only has 6 electrons. Okay, there are other atoms that other elements that have 6 electrons, but not only 6, right? Like nitrogen has 7 electrons. So it would make it to here, but this number would be 3. It would make it one further because nitrogen has 7 electrons. So it's another kind of way of identifying what element you have. Kind of cool. Okay, so helium, however, has 2 protons and 2 electrons, so it does fill that full orbital. Now we can put a 2 there. Can we put a 3 there? Can our 1s orbital hold 3 electrons? No, in fact, no orbital can hold 3 electrons. The max is 2. You don't have to have 2, right? We just saw that with hydrogen, but you need to, you can't have more than 2. Okay, so let's keep moving on. So when we're looking at the periodic table and we look at hydrogen and helium, let's take hydrogen first. If we're looking at hydrogen, we are in our S block, right? Let's put P over here, D over here, and F over here. We're in our S block, and we have we're in our first energy level. So we make it to 1s. So if I was going to write the electron configuration for hydrogen, I would put 1s, right? That's where I make it to, 1, first energy level, in my S sublevel. But I need to put how many electrons are in that orbital. How many electrons are in that orbital? Yeah, just 1. Just 1. And if you were confused, you could also count where hydrogen is on the periodic table. What do I mean by that? So let's look at helium and we'll come back to that. So if you're helium now, let's try helium. Helium makes it at least to 1s1, right? Because helium's all the way over here. Helium has an extra electron. So when you're writing out helium's electron configuration, what number goes here? Yeah, 2, because it has 2 electrons in its 1s orbital. Okay, so helium makes it through 1s1 to 1s2. Okay, so if you're looking from left to right, it goes through that and it ends up here. Okay, this is going to make more sense in a little bit here. Stick with me. Okay, so looking at period 2. So, again, let's go with lithium. Let's look at lithium. So lithium is right here. Whoops. Lithium is right here. So if we're at lithium, what period are we in? We're in period 2, right? This is period 1. Whoops. 1, 2, 3, 4, 5, 6, 7. We're in period 2 for lithium. And how many electrons does lithium have? Lithium has 3 electrons, right? Because it has 3 protons. And it's a neutral atom. So if we were going to write the electron configuration for lithium, we make it to 1s. How many electrons are in our 1s orbital? 2. We fill it, right? Because if lithium has 3 electrons, and here's my 1s, and here's my 2s. Remember, 1s, or your first energy level, only has an s sublevel, only has an s orbital. So we make it to our 1s. So I'm going to fill my electrons in there. And then I also have 1 in my 2s. Yeah. So I would have 2s. What number would go here? 1. Yeah. Pause the video and think about that. So if you're lithium, you go through 1s1, through 1s2, and you end up at 2s1. Do we make it to 2s2? No. If we did, what element would we be? Beryllium. Yeah. Because beryllium is going to make it through 1s2, right? It goes through hydrogen and helium. 1s2. And then it makes it through 2s2. 2s2, because I have 2 electrons in that 2s orbital. Okay, let's keep going. I think it'll make more sense as we do more examples. Okay, and I know it's already getting a little long here. Okay, now let's look at nitrogen here. So nitrogen is atomic number 7. So it has 7 protons and 7 electrons because it's a neutral atom. Here's the orbital diagram, right? We make it to 1s. We fill our 1s orbital. We fill our 2s orbital. And do we fill our 2p orbitals? No, because we don't have enough electrons, right? We only have 7. We've got 4 here. Whoops. 4 here. And we have 3 in our 2p orbitals. And remember, they're going to pair up separately like the bus. They're not going to want to pair up until they absolutely have to. So we call those unpaired electrons. Oops. Sorry, gosh. Okay, so if you were going to write that electron configuration, how are you going to write that? Well, nitrogen it fills its 1s orbital with how many electrons? 2, because that's a full orbital, right? It gets through that. Then it fills the next energy level, which is 2s2. Okay, then it fills how much of the 2p orbitals? Only 3. It only fills 3 electrons in its 2p orbital. How many can the 2p orbitals hold? How many electrons can your 2p sublevel hold? Your 2p sublevel has 3 orbitals. I should say 3, oops, 3, oh gosh. 3 2p orbitals, right? 1 and 2 and 3. And each of those orbitals can hold 2 electrons. Okay? So, since nitrogen only has 3 electrons to give, it can only have a 3 there for the p orbitals. 7 total electrons, but 4 are already taken up. Okay, so what's this weird notation here? That's actually called your noble gas configuration. And you'll see either noble gas configuration or abbreviated electron configuration. Either one of those, they mean the same thing. So what your noble gas configuration does is it shortens this electron configuration even more. So let me get rid of some of this writing here. So looking just at this helium, what is helium's electron configuration? Think about it. Helium's electron configuration is just 1s2 because, looking back at helium, I should have copied this down there. Looking back at helium, it makes it through your 1s1 and over to 1s2. Okay, so helium's electron configuration is 1s2. So you can use these noble gases to shorthand write out these electron configurations. You're abbreviating them a little bit. It doesn't show how useful it is when you're in this first or in this second period or row. It gets more clear how much of an abbreviation it is when you're doing like third row or lower. But it's still helpful. Instead of writing 1s2, you're writing helium. And the way that we write these noble gas configurations is by looking to the noble gas before your element. So if you're looking at nitrogen on the periodic table, notice that I'm not going to neon. Neon is a close noble gas, but we didn't make it all the way there, right? Neon is over here. We didn't quite make it over there. We filled our 1s1 and our 1s2. We filled our 2s1, 2s2. we filled our 2P1, 2P2, and 2P3, but we did not make it to this far, okay? So we look to our previous noble gas, which is helium. So you're always looking to the noble gas before, and that's because you actually filled that orbital with electrons. Okay, so you can use that abbreviation. Okay, so I hope that makes sense. Let's look at period 3. So period 3 gets a little bit more complicated. So looking at these electron configurations, look at argon there. Quite a lot going on there. And so that's when these noble gas configurations or abbreviated configurations can actually be really useful. But you need to know how to do the full version and the abbreviated version. So full, and then you can just call this noble gas, okay? Okay, so let's take a look at the 3s block. So let's look at sodium. Let's look at sodium. Sodium is Na, okay? So Na is in your third period, or third row of the periodic table. It's also located in your S block. So it doesn't make it to 3P, right? It only makes it to 3S. So when you're writing this out, we know it gets to 1s2. We know it fills the 1s orbital. It has enough electrons for that, right? We know it then fills our 2s orbital. It then actually fills all of our 2p orbitals. Remember, there's 6 electrons in our 3 2p orbitals. But then it only makes it to 3s1. Okay, so let's look at it up here. All the way up here, my gosh. Okay, so this is getting a little messy here. Get rid of some of that. Okay, so what were we looking at? Sodium. So sodium's here in period 3. So let's try to draw this. Let's try to figure out our electron configuration. So we make it through our 1s1, right? And then we also make it through our 1s2. So let's go ahead and write that. We have sodium. We have our 1s1. Oops, sorry, 1s2 because we filled it. Okay? Now, we're down here. Whoops. We're down here. So we also make it through. Oh my gosh, you guys, I'm sorry. I one day will remember not to do that. Okay, we also make it through our 2s1, 2s2, all the way through our 2p6. So let's put that on there. So 2s2 and 2p6. Okay. And then now we're in our what? We're in energy level 3. What block are we in? S. And how many electrons filled? Yeah, just one. Just one. We don't make it to 2. If we made it to 2, we'd be magnesium. Okay? So drawing our orbital diagram, we could do our 1s. We can do our 2s. We can do our 2p's. Remember, there are 3 of those. 2p, 2p, 2p. And then we can do our 3s. Okay, so we fill in our electrons. We have one up, spin up, one spin down. Boom. How many electrons do we have total? 11. Okay, so we got 2, 3, 4, 5, 6, 7, 8, 9, 10. We filled our P's. Notice how I filled those in. And then we even have one in our 3s. Okay. Okay, stick with me, you guys. I know these are long videos this time. There's a lot to cover, though. Now, our 3p block, same idea, right? You can get all the way to 3p6. Remember, your p block, your p sub level has 3 p orbitals, and each of those orbitals can hold 2 electrons, so that's a total of 6. Okay, and then looking just real quick here at the noble gas configuration, let's look at chlorine here. So for your noble gas configuration for chlorine, notice that electron configuration is this entire thing in blue here. So what are we doing when we're writing neon and then the other stuff? We're just showing our highest level energy levels. Our highest level, our electrons in the highest energy level, which is 3. Yeah. So that's another thing about the noble gas configuration, is it really kind of shows the most important part of our electron configuration, because what we really care about, and you'll understand this more in the future, is our highest energy electrons, our highest energy level electrons, because those are the ones that are going to participate in bonding. Okay, so when we look at this, we can see, okay, which electrons are participating in bonding? Oh, probably the ones in that 3p5. Yeah. Okay, hopefully that makes sense.